Hi, let us continue from where we stopped. If you remember, we finished with the 9th question in the previous video. So I'm going to start with the 10th question. The 10th question is a very direct problem. It doesn't require too much of extra understanding. You can just do it based on what you've already learned. It is 12 plus 1 5 by x, less than equal to 5 plus 3x. And they've told us that x belongs to real numbers. So I'm just going to simplify this out a little for you and then ask you to finish it off. Very easy. You can pause the video and finish it off immediately. Alright, now that you've done with this, let's move into the 11th question. In the 11th question, he says x belongs to integers, which is z. Let me put up the equation for you. It is minus 5 less than equal to 2x minus 3 less than x plus 2. So now if you see, there are two inequality signs. So in problems like these, you need to split them into two parts. This is going to be the first part, which I shall write minus 5 less than equal to 2x minus 3, and the second part is going to be the other inequality that you see, which is that one. So I'm going to write that as well. The other inequality is going to be 2x minus 3 is less than x plus 2. Alright, so we are going to solve each one separately right now. So let's solve the first one. The first one is minus 5 less than equal to 2x minus 3. So minus 2 is less than equal to 2x. So I'm just going to simplify that out a little. I'm going to get x greater than or equal to minus 1. So I'm going to call that equation 1. The second one is going to be 2x minus 3 is less than x plus 2. So I'm just going to push x on the left hand side. So I'm going to get x less than 2 plus 3, which is x less than 5. So now I've got two parts to it. I've got x greater than equal to minus 1, which I shall write. Let's go back. I have x less than 5. So I'm just going to club both together and let us try and understand what this really means. When we talk about this, it means two things. One, we are looking at all integers that are greater than equal to minus 1 but less than 5. So think of all integers that are greater than or equal to minus 1 but less than 5. So this basically means you're looking at integers that are between minus 1 and 5, in which minus 1 is also included. Alright, which basically tells you that the integers are minus 1, 0, 1, 2, 3 and 4. Alright, and that will be the solution to your linear inequation. So you're looking at all integers between minus 1 and 5, which also includes minus 1. Please pause the video at this time and finish off the problem. Now that you have done that problem, I want you to use the same concept and finish off the 12th question. In the 12th question, again you have two inequality signs, but the only difference is here x belongs to whole numbers. In the previous case, it belonged to natural numbers. And remember, when it belongs to whole numbers, you only have to consider positive integers including 0. So again, split it up into your two inequalities. First one is going to be minus 1 less than equal to 3 plus 4x. The second one is 3 plus 4x is less than 23. Alright, I want you to try this on your own. This is very simple. Okay, please pause this video at this time, finish the problem, and then we'll take it forward. Alright, now that we've completed the first exercise, I'm going to introduce you to the second part of the chapter, which is Introduction to Number Line Representation. We're going to do about 9 problems in this exercise for today. It is mostly representing all the solutions that we have obtained from the previous exercise onto a number line. I'll just give you a little idea on how this is going to work. Alright, so I'm just going to put up the heading for you. We are talking about representation of a linear inequation solution on a number line. Okay, so this is how this is going to work. I'm going to take one very simple example. Let us take an example of, I'll give you the solution itself. Let us think of putting a solution of 1, 2, 3, 4 and 5 on a number line. So how this is going to work is, I'm first going to draw the number line. That is how it's going to be. I'm going to represent arrows on both sides because you can extend it indefinitely. Then I'm going to put the numbers on the number lines, which is going to be 0, 1, 2, 3, 4, 5. It's going to have both positive and negative numbers in it. So I'll fill it up with these numbers because this is pretty much what I need. And the numbers that I need to represent are represented by full dots, like the way it's being represented, which is 1, 2, 3, 4, and 5. This is pretty much what you do to represent the solution on the number line. Just draw a number line and put them in the form of dots. Now let us look at the second question. We are looking at all numbers that are less than 7 such that x belongs to natural numbers. So you're looking at all natural numbers that are less than 7. So think of all natural numbers that are less than 7. Your solution set would be 1, since the natural numbers 1, 2, 3, 4, 5 and 6. All natural numbers that are less than 7. Now let us put all that together. Once we put all that together, let's draw the number line. Remember, we need to represent all natural numbers that are less than 7. So I'm going to write a few numbers on the number line. And then I'm just going to highlight all the numbers that I'm supposed to, which is going to be 1, 2, 3, 4, 5 and 6. I'm just going to go to those numbers and fill up full circles like the way we see. And that is going to be your solution. All right. You could just say x belongs to n, and that is pretty much how you would represent it. All right, we're going to do some more of this so that you understand it clearly, and then we'll get to the exercise. Now let's look at another problem. X plus 3 less than 7, x belongs to whole numbers. What would this look like? I want you to try this on your own. It's actually very easy. First, simplify your linear inequation, get the solution set, draw the number line and mark it. You can pause the video at this time. Alright, so this is how your number line is going to look. First, let us write the solution set. Your solution set is going to be x plus 3 less than 7, so x becomes less than 4. So think of all whole numbers that are less than 4, which would basically be 0, 1, 2 and 3. Alright, so I'm going to just mark dots on these numbers on the number line. So let me first fill up the number line. So I'm going to put 1 on 0, 1 on 1, 2 and 3. Alright, then I'm just going to say x belongs to w, indicating that all the values of x are whole numbers. Alright, now let's move into the fourth question. Fourth question is x plus 4 is less than 10. X belongs to R. Now here you'll have to be a little careful, because when you deal with real numbers, it's slightly different compared to the others. So first what I'm going to do is I'm going to simplify the linear inequation. So I get x less than 6. Once I move 4 on the right hand side, I get x less than 6 and x belongs to R. So what I'm going to do now is I'm going to understand what this really means. We are looking at all real numbers that are less than 6. Right? So think of all real numbers that are less than 6. So first I'm going to draw the number line. Alright, and then I'm going to mark all the numbers. So I have 0, 1, 2, 3, 4, 5, 6. I'll also mark a few negative numbers. I'm going to put a -1, a -2, a -3, etc. Now think of all natural numbers that are less than 6. Now since it has a less than, on 6 I'm going to put a circle like the way I have. I'm not going to shade the circle. It's just going to be a circle. And then I'm going to shade all numbers that are less than 6, which would pretty much be all the numbers on the left hand side, including the arrow. So this would pretty much indicate all real numbers that are less than 6. Alright, so a 5 or maybe a 2.5 are all real numbers that are less than 6, and this is how I would represent it on a number line. Keep in mind that if it is less than, I will just put a normal circle. Alright, we'll be doing many more examples so that you understand different ways in which you can represent this on the number line. This is actually quite simple. Alright. Now let's move into the next question. You can pause at this point if you want to do it yourself, but there are many problems from the exercise that you would anyway be doing. I have x less than equal to -2 and x belongs to R. Alright, so let's look at a number line. So here we are looking at all real numbers that are less than equal to minus 2. So I'm just going to put this on the number line first. Alright, now it says x is less than equal to minus 2, which means minus 2 is also included. So instead of putting a normal circle, I'm going to put a shaded circle like the way I have, and I'm going to shade everything on the number line which represents any value that is less than equal to minus 2, including the arrow. The only difference is in the previous problem, since it was less than, I would just put a normal circle. Since it is less than equal to here, I'm going to put a full circle. That is the only difference that you have to keep in mind. Alright. Now that we have finished this, I'm going to give you one more that I want you to try on your own. This is actually very easy. This is minus 4 less than x less than 3, and x belongs to natural numbers. Now think of all natural numbers that are between minus 4 and 3. Now you need to also recollect that natural numbers start from 1. So when you think of all natural numbers between minus 4 and 3, there are no natural numbers that are less than 1. So your solution set is only going to be 1 and 2. So these are the only natural numbers that are less than 3. So on the number line, you're just going to mark dots on 1 and 2. Alright, I hope this is making sense. If you have more questions, please write. Otherwise, please put your comments in the comment box so that we can look at it and review it. Alright, now let's look at the 7th question. These are not in your textbook. These are few questions that I have put in myself so that you understand how this works. Here we have another one where x lies between minus 4 and 3. They belong to real numbers, but minus 4 is included here, 3 is not included. First I'm going to put the number line like this, and then what I'm going to do is I'm going to look at all the numbers that are included and ones that are not. Since 4 has less than equal to, 4 will have a full circle, 3 will have a normal circle because it is just less than 3. And then real numbers means that you're going to shade everything between them. Then it's preferable that you write the equation on top of the line. So it's going to be minus 4 less than x less than equal to x less than 3, and x belongs to R. Alright, so this is how we're going to work with this. Now I'm just going to summarize everything we've just done so that you're clear with the concept, and then we can start working on the problems. Now the first point is, for natural numbers, whole numbers, integers, all we have to do is write the solution set. So we'll write the solution set and then just represent them directly on the number line. There is nothing much for us to do. You may have to simplify certain inequations here and there, and once we simplify them, all you have to do is mark those points on the number line and you're good to go. Alright, the only difference is how you represent numbers that are real numbers. So for real numbers, what we're going to do is we're going to first check if there is an equal to involved in the inequality sign or not. So if it is less than equal to or greater than equal to, then it is presented with a full circle like that. So I've just put a full circle. If it is just less than or greater than, then we're not going to put a full circle, we're just going to put a normal circle. So else we will put a normal circle which is represented like this on the number line. Alright, so just keep these two things in mind. If it is less than equal to or greater than equal to, on that particular number put a full circle. If it is less than or greater than, on that particular number you just put a normal circle. Take a screenshot of this, or just make a note of it so that we can start with the exercise problems. Alright, let's start with exercise 4b. We'll approximately do about 9 problems in this, maybe a little less than that too, because you're just warming up to understanding how this is going to work. So let's take the first question. Now generally if they don't specify what family of numbers they belong to, assume that it belongs to real numbers. So let's take the first question. I have 2x minus 1 is less than 5. So I'm just going to simplify this out a little to get the solution set. So I'm going to write 2x less than 6. So x is less than 3. So I'm looking at all real numbers that are less than 3. So let's put this on the number line. Very easy now that you know how it's going to be done. Since it's less than, I'm going to put a normal circle at 3. Alright, so here comes the number line. I'm going to put arrows on both sides to indicate that it can be extended indefinitely. So I'm going to put minus 1, 0, 1, 2, 3, 4, fill it up completely. Alright, so at 3, since it's less than, I'm going to put a normal circle. And since we are looking at all numbers that are less than 3, shade all numbers that are less than 3 on the number line, including the arrow. And that becomes x less than 3 and x belongs to R. Alright, it was a simple one. If you've understood what to do, you can proceed with the next two problems. The other two problems are very similar. You'll have to just follow the same process and finish it off. So pause the video at this point in time and finish the second problem and the third problem under this. Okay, now that you've done the second and the third problem, please verify your answers. Let's move into the fourth question. The fourth question is also quite similar. We have done something like this in one of the examples that I covered in the beginning of the video. I have minus 4 less than x less than 4. It all belongs to real numbers. So first mark your real number line, mark all the numbers on them. I have minus 2, minus 1, 0, 1, 2, 3. If you feel your number line is small, you can just extend it like the way I've just been doing. Just extend the line out a little, mark 5, but make sure that the difference between every number is pretty much the same. So at 4 and at minus 4, I'm going to put normal circles because it's just less than everywhere, and I'm just going to shade the region between them. Write the equation on top of it. So that's minus 4 less than x less than 4 and x belongs to R. Alright. Let's take the fifth question. Fifth question is also very similar. I'm sure all of you can try it on your own. I'm just going to put the question up for you. Minus 2 less than equal to x less than 5. Please try it on your own. You can pause the video at this time and finish it off. Now I'm plotting the number line. Put arrows on both sides. Let's go back. Let's see what it's. Minus 2 and 5. So at minus 2, I need to have a full circle. At 5, I need to have a normal circle. Alright. So let's quickly put that in place. I have a 4 and a 5. So at 2, I see an equal to, so 2 must be included. And at 5, I must not include it. So I'm going to put a normal circle at 5. And then I'm going to shade everything between that. And that is pretty much going to be your answer. Alright, so put the equation on top of it so that you know what to put in there. Once you put in your equation, it will become very simple for you to also interpret if your answer is right or wrong. So that's minus 2 less than equal to x less than 5 and x belongs to R. Alright, I want you to try the sixth and the seventh one on your own. They're all very similar to this. So once you understand this, the next two problems become very easy and direct. Alright, please pause the video at this time and finish off the problem. Alright, let's look at the second main in this. The second main is he's asking you to represent the given number line in form of a solution set or as an equation. Assume everything belongs to real numbers here. Now that he's not specified it, just assume it belongs to real numbers. Let's look at how to interpret the first question. Now if you look at the diagram that is given, the real number representation that has been given, I'll quickly put that up for you. So I have a minus 1, minus 2, minus 3, minus 4, minus 5, and then he's put a full circle at minus 1, which means minus 1 is included, and then he shaded everything to the left. So these are all real numbers that are definitely less than minus 1, which also includes minus 1. Please read that as minus 1 instead of 1. So you're basically looking at all real numbers that are less than or equal to minus 1, and that itself is going to be your equation. So x less than equal to minus 1, x belongs to R would be the method in which you would represent the number line in the form of an equation. And everything that is circled there are numbers that are less than minus 1. All these are real numbers, and remember, real numbers are those that can be represented on the number line. They could include fractions, decimals, and all of that. So x less than minus 1, x belongs to R would be your solution. Keep the same thing in mind when you try the second one. Second one is something you can easily try. It's all right there. Just look at whether you need to include the number or not, depending on the type of circle that has been encircled around the number. Please pause the video and finish the question. Okay, let's look at the third one. Third one is probably slightly different because there are two things that are specific there. I have a minus 4, a minus 3, minus 2, minus 1, a 0, a 1, 2, 3, and 4. I'll just extend the line a little. And let's see how this is represented. I see a full circle on 4. I see a normal circle on 3. So it's basically all real numbers that are between minus 4 and 3. You must include minus 4, but you must not include 3. So think of all numbers that are between minus 4 and 3. I'm going to put less than equal to 4 because I need to include the minus 4, but I'm not going to put less than equal to 3. I'm instead just going to say less than 3, so that we understand that these are all real numbers that are between minus 4 and 3, which includes minus 4 but does not include 3. Alright, so that is how you would verbally represent it, as all real numbers between minus 4 and 3, which also includes minus 4. Alright, I hope this is making sense. Let's move to the next question. I think with this information you can try the fourth one. Please try this. Please pause this video at this stage and finish it. Okay, now that you've understood it, let's start from the third one. I have x belonging to R real numbers. This is the equation that I have. I have two inequalities, so I need to look at them as two different equations. So I'm going to take the first one as minus 4 less than equal to 3x minus 1. I'm going to transfer it this side. So I'm going to get minus 3 less than 3x. And I'm going to get minus 1 less than x. I'm going to get 3x minus 1 less than 8. So I get 3x less than 9. So x becomes less than 3. So I'm going to put both together. So I'm going to get minus 1 less than x. And I have x less than 3. Now I'm going to just combine them together. Minus 1 less than x less than 3, x belongs to R. Alright, so I think it has to be x less than equal to minus 1. So sorry for that error, please correct it when you're doing it. So it's minus 1 less than equal to x less than 3. So what you'll have to do is you'll have to put a normal circle at 3 but a full circle at minus 1 and shade everything in between. So don't go by this solution. Make sure that you shade the circle at minus 1 completely. Alright, so it has to be minus 1 less than equal to x less than 3. Alright, so make that small change please. Alright, let's go into the next question. I want you to try this on your own. Very simple, just like the previous one. Just don't make the error I made in the previous problem with respect to the sign. You please be a little careful on that and try it. Please pause the video at this stage and finish it. I'll put up the solution for you right now. I have x minus 1 less than 3 minus x less than equal to 5. Take the first inequation and then later take the second inequation and solve it. So x minus 1 less than 3 minus x is going to be your first inequation. 3 minus x less than equal to 5 is going to be your second equation. Put that together, pause the video at this place, get the solution set and solve it. Okay, I think you're good to go. You can finish off the fourth and the fifth question right now. The fourth and the fifth question are very similar to what we've just done. Very, very easy. And I think with that you should be able to cover some good part of the exercise. Remember, today's class is just an introduction class, so we'll be covering only up until the fifth question. I hope all of you understood how this works. I'll see you guys tomorrow. Have a good day. Bye bye.